Alright, this video is an extension from our last video where we were investigating how we could solve oblique triangles. Those are those non-right triangles. This is going to be part 2 where we use the law of cosines. In the last video we used the law of sines, and we talked about two special cases in which we couldn't use the law of sines, and we hinted that we were going to have to use the law of cosines. So those two special cases are side angle side or side side side. So if that's the given information, we're going to use the law of cosines to solve. Side angle side is going to look like we're given two consecutive sides, two sides right next to each other, and the angle in between. If those are the measures that we're given, well, then we're going to use the law of cosines. Or instead, if we're given all three side lengths, we're going to use the law of cosines to find our angle measures. So a couple of different ways that we can work with our equation. Here is the most generic form of the law of cosines, typically what you're given. It's solving for side C. However, notice that it's not even set up for that quite yet. In order to solve for C, we would have to square root both sides. So that version of the equation is probably more helpful. Another way that we can use law of cosines is to solve for angle measures. So notice right here at the end of our equation, we're going to be plugging an angle measure in. So if instead we have these three sides, we're going to be able to solve for cosine of C. So we're going to use some algebra to set that up in a minute. Let's talk about two other forms of the equation we could use. Rather than solving for side C, we could instead perhaps need to solve for side A or side B. It doesn't really matter what you call these side lengths. It just matters how they relate to each other. So I think that's a little bit more important to understand rather than trying to memorize or use three different forms of this equation. Here's how the law of cosines works. For whatever side that you are solving for example, if we were solving for side A, our equation is going to need the other two sides and the angle across from the side. So that's always going to be how these parts relate to each other. Notice here, if I wanted to solve for side B, well then I would use the other two sides, C and A, and angle B. Alright, let's solve for the measure of the angle. We're going to do it algebraically first. It's going to help us quite a bit to have another version of this formula rather than having to plug side lengths in here and then solve for the angle. We're just going to come up with an equation that we can use every time we need to do that. So algebraically, if we were to take, well, two different ways we kind of describe it. If we were to take b squared and c squared and move them to the left side, so subtract them from both sides, then on the right side would still be negative 2 times side b times side c times the cosine of a. And so to get to our cosine of a, to isolate that variable, we're going to divide and undo all this multiplication. We might as well do it all in one step. So we'll divide everything by negative 2 times b times c. And now we have cosine of A is equal to this mess over here. And one more thing I'm going to do, just to try and simplify things, is get rid of my negatives, or in other words, factor out a negative 1. So b squared is now positive, c squared is now positive, but this positive a squared is now negative, and this bottom is now positive. So just a different way to organize it. Not totally necessary, but it looks a little better. To solve for angle A, we're going to have to undo our cosine function, so we'll inverse cosine both sides. And if we do the inverse cosine of this complicated ratio right here, we'll get the measure of our angle. So one more time, let's talk about the pieces that are used in that equation rather than trying to memorize or identify things relative to these letters. So if I wanted to solve for angle A, I am now going to use the two sides that are next to that angle. I'm going to add the squares of those sides, and then I'm going to subtract the square of the side across from it, the opposite side. And when I divide, I'm going to divide by double the product of those two sides that are next to my angle. Alright, so you could, again, set that all up relative to those angle names if you want. but I'm going to try and get you used to just identifying the parts rather than what letter they are. Alright, so let's do a couple examples here. The first example we see, we're given the parts for side, angle, side. So identifying that that is what's given to us will hopefully remind us that we have to use the law of cosines. So I'm going to solve for this third side, because in order to solve for the angle measures, I need all three side lengths. You could try and solve for one of your angles first, but you're going to hit a dead end, so don't do that. Let's solve for all three sides first. So solving for side DF, what I'm going to do is I'm going to add the two other sides, the square of the other two sides, sorry, and then I'm going to subtract double the product of those other two sides times the cosine of that opposite angle. So from here on out, it's just a lot of calculator button pushing. Squaring 25 and squaring 10 and adding the sum of that gives me 725. Then over here we have a bunch of things being multiplied. So we have a negative 2 times 25 times 10 times the cosine of 119. What I like to do on my calculator is take the cosine of my angle. Make sure you're in degree mode, otherwise it's not going to work out quite the same. I like to do this, evaluate the cosine of your angle first, and then multiply each of those things by those three values there. When you take the cosine of 119, you're going to get a negative value. So a negative times a negative is going to give me a positive. So I have a positive amount over here. I'm going to add that to my original amount of 725 and then square root it. And that gives me my side length, about 31.1. We're in kilometers for our units in this example. There is a common mistake that tends to happen when evaluating what's inside here. Again, take the sum of the squares and keep that value separate than your product over here, and then combine them second. That tends to hopefully fix a lot of mistakes that happen right there. Now that I have all three side lengths, I'm going to be able to solve for one of my angles that's missing. It actually doesn't matter which one you do. I'm going to solve for angle F. You can challenge yourself to solve for angle D and see if we get the same answers here. When we use our inverse cosine to solve for our angle, this equation right here, angle F, we're going to use the two sides that are closest, and we're going to square those and add them together. So 10 squared plus what we just solved, 31.1 squared. Then I'm going to subtract the square of the side that's opposite or farthest away. And doing all that, I get about 442.21. On the bottom, I'm going to double the product of those two sides that I started with, the two closest sides. So 2 times 10 times 31.1 is going to give me 622. Now I have a ratio that I can plug into my inverse cosine function. And my calculator in degree mode will tell me it's about 44.7 degrees. So there's angle F. Now that I have two angles in my triangle, I can just use properties of a triangle to figure out that last angle. All three angles are going to add up to 180. So add up the two that we know, 119 and 44.7, subtract that from 180, and we get our last missing measurement. Angle D is about 16.3 degrees. So if you had inverse cosine to solve for angle D, well then you would use the two closest sides next to you, 25 and 31.1. So they would be the two squares that we add together. I would subtract the square of the side opposite, so that 10 squared would be the subtracted one there. And then on the bottom, 2 times the product of those two sides that were closest to my angle, 25 and 31.1. And then if you inverse cosine after simplifying that, you should have got 16.3. Then you can go ahead and use that property of triangles again. Add up the two that you know, 119 and 16.3, subtract that from 180, and you would get angle F there, 44.7 degrees. So there's side angle side. Again, make sure that you solve for that third side first in order to solve for your missing angles. Just the slight trick there for those. Last type, we got this side, side, side. What if we're given all three side lengths? Well, we're going to have to solve for all three angle measures. And we just said that that's possible if we know all three side lengths. So it doesn't matter which one you start with. Pick one. I'm going to start by solving for angle P. Oh, again, if we're just given a description, it might help to sketch it out. I like to visualize it. Again, it doesn't matter as long as you put your P, K, and H at your vertex points representing your angles, and then the side lengths represented with a lowercase letter are always going to be opposite or across from those angles. So side H is across from angle H. Side K is across from angle K, and side P is across from angle P. All right, so again, I'm solving for angle P. I'm going to take the inverse cosine. I'm going to take the square of the two side lengths closest to my angle. I'm going to add those squares together. So 17 squared plus 10 squared, and then I'm going to subtract the square of that side that's farthest away or opposite. I get about 325. The bottom, I'm going to double the product of those two sides that were closest again. So 17 times 10 doubled is 340. Now I have a simplified ratio, and I can plug that into my inverse cosine function. Calculator tells me it's about 17.1 degrees. So there's angle P. Next, I'm going to solve for angle K. Although you could solve for angle H if you want. Challenge yourself and see if we get the same answer here. For angle K, inverse cosine, what I'm going to do is take the square of those two sides closest to my angle, add those squares together, and then subtract the square of the side that's farthest or opposite. Doing that, I get 253. Doubling the product of those two sides that were closest to my angle. So 17 times 8 doubled is 272. Plugging that into my calculator, the inverse cosine of that ratio tells me it's about 21.5 degrees. Now that I have two angles, I can add those up and subtract that sum from 180 to get my third angle. So angle H is about 141.4 degrees. So there's how we do side, side, side versions. And to solve for those angles, use those inverse cosine equations. So good luck practicing the side, 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 and side angle side versions of these oblique triangles and using the law of cosines. Let me know if you have any questions.